In our last video, we learned what a method is. That a method is a name for a sequence of instructions, and that we run a method by, we say we call the method by writing this thing here. And the key that tells us that we want to define a method is whenever we're copying and pasting. When we're copying and pasting, alarms should go off in our head. There's got to be a better way. When we copied and pasted turn left 3 times over and over again in our program to solve the maze, that signaled that there must be a better way. Maybe we can define what it means to turn right, that turning right means turning left 3 times. We also learned that to call a method, we write the name of the file, and in the case that we were seeing, our file name was lesson, and then the name of the method. Our method was called turn right, and some weird punctuation. So this word lesson here, that's the file name, that's the name of our file, and this word over here, turn right, that's the method name of the method. So when we say robot.move, that tells us there's a file called robot, and inside it has a method called move. And indeed, we can look that up. Let's do that. Open the robot file, and there's a bunch of scary stuff in that robot file, but if we look for it, we might just find that there it is, a method defined called move, and ooh boy, I don't know what any of those things mean yet, but we can celebrate that at least we understand that there will be something in the robot file called move. Alright, so let's go back to lesson where we created something called turn right, and what I want to see is can I rewrite my solve to use turn right? Well, I can. So right here, where I turn left 3 times, we'll just say turn right, and the file name is lesson, turn right, the parentheses, the semicolon. By the way, if I don't have, let's see some error messages. If I don't have the semicolon and I hit the compile button, it's off the screen, but trust me, it says compile there. You can see some of the error messages we'll start to see all the time. It says semicolon expected. Well, that was very friendly and correct. It did expect a semicolon. Okay, I'll just type that semicolon. Now let's try, what if I don't have the parentheses? What does that do? Compile, and it says not a statement. Okay, so apparently, oh, there, now it's on the screen. Apparently these things are called statements, and I don't have a statement because I haven't written it correctly, so we'll put the parentheses back. This time we'll see what happens if we don't have the period. Okay, I hit the compile button off the screen, and it says it can't find a symbol, can't find any method called lesson turn right. That's because it's not called lesson turn right, it's in the lesson file, and it's called turn right. Okay, let's compile that, and it says it's completed, it's happy. So let's see if we can shrink this. So everywhere we turned right, everywhere we turned left 3 times, we'll turn right. Where else did we do that? Oop, here's one. So this is a turn right. And this is a turn right. And this is a turn right. What else did we do very, very often that might be a helpful thing to define? Well, if you look at our maze, let's go look at that maze again. Robot.load maze.txt. If I look at the maze, I see that it's actually a nice even maze, and I actually always move in chunks of 2 steps at a time with the way this maze is set up. So one thing I might define is a method that moves twice in a row. Let's do that. So I define a new method, public static void. I'll call it move2. And yes, I can have numbers in my method names as long as my method name begins with an alphabet character. I can do that. And let's see, move2 should move twice. And now I can take all of these move bundles and say lesson move 2 times. So sorry, I'm replacing 2 moves with that. Now I'm going to replace another 2 moves, and another 2 moves, another 2 moves, and we see there were lots of places I was moving twice in a row, so this is a useful method. I'm not sure it's dramatically more readable. It still looks like gibberish to me when I look at this file. I'm not actually sure why I'm even doing this anymore. Hey, that's interesting. I had only one move here. I bet I meant to move twice. And indeed, I think that will fix the program, the bug, the error, the bug in my program that we introduced before. Okay, let's compile that. Good. Let's see, it compiles, so let's try running it. Load my maze, put it on the screen, and let's go ahead and run it. So you can actually see. Lesson.solve. Oh, and by the way, I can use lesson turn right if I want right now. Look at all that turning right by turning left 3 times. But we can ask it to do solve, which performs the whole task, and we'll see how well it does. Doing pretty well. Let's try defining some other instructions. Hey, we got it. Excellent. Let's define some other instructions. So we got turn right, we have move to. How about turn around? Turn around. In other words, face the other direction. How am I going to face the other direction? Well, I will ask the robot to turn left twice. Or, if we want, we could turn right twice, although we know that will really mean turning left 6 times, and that might drive us crazy. Let's just trust the turnaround works. I'm sure it works. Why would I do anything incorrect? I'm sure it works. Let's try something else. Let's do a much more interesting one. Back up. Back up. And the purpose of back up is to tell the robot to take 1 step backwards. Okay, let's take a look at my world. How is the robot going to take 1 step backwards? Well, it's going to have to turn around, move. Okay, let's try that. Turn around. How do we turn around? Well, I call the turnaround method I just wrote. I can call turn left 2 times, but turn around is so much nicer. And turn around is in the lesson file. By the way, some of you may know enough Java to know that I actually don't need to write the name of the file if I'm calling a method that's in the same file I'm writing. My file is called lesson, so I don't actually need to write it, but I'm going to write it because I think it's helpful to see for a while. Turn around and then move. Let's try that. Turn around and move. So I'm compiling. You can't see me, but I move off the screen to compile. It's happening. Trust me. And we'll load up that world again. Put it on the screen and test out my backup method. I guess, notice I better move forward before I back up, right? Okay, so we'll move and we'll ask it to back up. Notice I'm saying lesson.backup because backup's in the lesson file. And did we succeed? Did the robot back up? Not really. It moved to the square behind where it started. But it's very surprising. If we didn't know this was going to happen from looking at our program, it's kind of surprising that it's facing a different direction than it was before. So let's fix that. That means we should turn around. Let's pretend we're backing up now. We turn around. We're facing down now. We move. We're still facing down. If we want to face the original direction, we will need to turn around again at the end. Okay, I'm going to hit F5, by the way, which compiles for me. There we go. And load my maze again. Put it on the screen for you. And let's try this. Move. And now show me backing up. Ta-da! Alright, now I'd like to see what happens if I back up when I can't. Do you have any predictions what will happen if I ask it to back up now? So you might be thinking, well, it won't do anything because you can't back up. But that's not what Java's going to do. Java's going to say, well, let's see, back up. That means I turn around. Turn around, that means I turn left twice. And then having turned left twice, I move. And the move is going to cause me trouble. So let's see that happen. Back up. So the turning around happens, and then the move fails. And you can see it says, it attempted to move, we'll skip the rest, on line 25 of lesson. And on line 25 of lesson, you can see there's my attempt to move, and we crashed. So, we just learned something important. We learned that you can't always call back up. So, often it's a good idea to write out what should be true before my method is called, and what will be true after. So, before, Well, what has to be true before? The back must be clear. There can't be anything behind the robot. What will be true after? Well, the robot will have moved one space back, facing in its original direction. So notice I'm using comments here. I'm commenting just for myself so that I know what the backup method is going to accomplish. It will move one step back facing the original direction. And I can think of this as lawyer speak. I'm basically saying, I promise that my backup method will move one step back facing the original direction, but only if you guarantee me the back was clear at the beginning. If the back was not clear at the beginning, I am not responsible for what this program will do. Whatever it does, it does. It's your fault. You should have made sure the back was clear before calling it. In our next video, we'll get a better sense, I think, of these methods, what they do, and then we'll start moving towards solving some more interesting problems with bigger and more intricate methods. I'll see you there.